Hey everybody, welcome to Hilltop Machine Works. Well, hey guys, it's Tom here. We are back on the Boyar Schultz and it is time to cut this gear here. This is the spur gear that runs on the rack that basically moves the table back and forth on an x-axis, and hopefully you guys can see it, but she is extremely worn. Look how sharp those teeth are. So it was originally in this shaft here, and the hand wheel goes on there. It took me a while to figure it out because I originally thought it was pressed on, and I started playing with it, and you can see it's got quite a bit of play. So I was like, all right, well that's not the case. And I finally found the the place where there had a pin driven in, because it was mashed down. If you can see, let me get my scribe here, but if you can see how it was the metal hitting metal, and it started to form, and how it made these indentations. Well, it made the indentations and moved the metal down, and I couldn't find the original pin. So cleaned it up real good and finally found it, and noticed it wasn't a split pin, so I was betting it was probably a tapered pin, and then I tried to figure out which side is bigger and which side is smaller to drive it through, and finally able to get it out, and it was a split pin. I'm sorry, God. It was a tapered pin, not a split pin. And you can even see how the how it wore, and the depth of the tooth there is actually in the pin itself. So I was able to drive this thing out. So plan is going to be, I've got this hunk of 1144, which will be perfect, and this is the right diameter. So not to bore you guys, but we'll do a quick little class on gear cutting. So I've got this little book here, Gears and Gear Cutting by Ivan Waugh. It's number 17. There's a whole series on this little classes, so to speak, you know. So I mean, you can get on drills and drill and tapping, and you know, metal working. You know, like I said, this is gears and sheet metal work. So you know, if you need something particular topic, these are great little books. I got this one off of eBay, but Amazon sells it also. So you know, I figured out a few, obviously, numbers that I needed, so you know, you can count your teeth and figure it out. So it was a 16 diametral pitch, 14.5 degree pressure angle. You know, you count your teeth, so I figured it was out. That was 18 teeth by counting them. Measured the thickness. This is 1/2 inch thick. The ID is actually 625, and this shaft measures 619 on the end here, so I don't want this much slop. So I am going to just do a nice 1 thou slip over. So we're going to make this inner bore 0.620, and what I needed to figure out was the OD of the gear, because of the wear. It was measuring kind of small. So coming over here, looking up my book. So you've got your formulas down through here, and there's the OD. So you take N, which is the number of teeth, plus 2 over the diametral pitch. And so that's that. 18 plus 2 is 20. 16 diametral pitch gives me 1.250. Hope this isn't freaking you out, but my 8-foot light above me is flickering. That tube is kind of driving me bonkers there, so I hope it's not too bad on the video. And then next I need to figure out my depth of cut. So going back over here, my formula for that one, depth of cut is D plus, and depth to set cutter, plus they give you clearance in there, so that's 2.157 over the diametral pitch, and so that comes out to 0.134. So that'll be the depth of cut that we'll use when we run this influte cutter here. This will be what we'll be cutting the teeth. These are imports, but so they number them differently. This is a number 3 for them, but on the normal American-made system, this should be a number 16. I'm sorry, number 6. So something to note when you buy import ones, make sure you check. See, this is 17 to 20. That you can't go with that, the number that's usually corresponds to the gear, because they do it differently. So I think the first obviously order of operations is going to be is we'll cut our gear blank off of this, get the bore, get that all done. I'll have to make a mandrel to hold this, and once we get that lathe work done, then we'll go over to the milling machine, and I'll use that new dividing head that I picked up a couple months ago. I showed you guys on a mail call, that nice L&W dividing head, and we'll get that all trimmed in, and we will cut us a gear. So let me move the camera around. Alright, just faced it off, nothing fancy. Let's break this corner here. Alrighty. Now let's go ahead and I'm gonna go ahead and center drill it, and we'll poke a hole and get this thing set up. What do you guys say? Cutting it dry. Go a little more than 1 inch. See, should be ½ an inch. I go a little bit more for the. All right. This is 9/16. A little fast. We'll get through it real quick here. Alright, at the bottom of the hole. Alright, start boring this thing out to 0.620. Just going to do a cleanup pass from drilling that 9/16 bit in there, and then we can get a good measurement to go off of and see how much we got to take off. Alrighty, I've been just run a couple passes, And we are at 6:09. So I've got, 11 more thou to go. Okie dokie, fingers crossed this is the last pass. Like I said, this measurement isn't critical, but I just like a nice fit on the end of that shaft. Don't want it sloppy like it originally was. Alrighty, we got our hole done. This is a 621, or actually, since it's a minus, it's gonna be like a 620 and, let me see. It is 620 and 8/10. 8/10. So just goes in. You can hear that, just a little bit of suction fit, so I am pleased with that. She fits in nice. So way better than the old one. So alright. So let's get this thing cut to its width. Alrighty, just trying to part her off a little bit here. Wants to chatter just a little bit if I can't get the feed fast enough in there. I slowed her way down. There we go. Alrighty, one spur gear blank. Okay, got her flipped around. Let's get her faced, and I gotta take 10 thou off. Just hand feed it real quick. Alright, we should be there. Just calipering it for this. 5/00 and 5/10. Doesn't get any better than that. Sweet. Alright. So, next thing I need to do is basically make an arbor for this thing to hold it in between the dividing head and the tailstock. Okay, see if I can show this with enough light and with you guys kind of over my shoulder. So getting ready to basically make the arbor to hold our gear blank, and got my dividing head and my tailstock. So a couple things to consider when you're making an arbor is you got enough room. So the cutter's going to start, you got plenty of room between your chuck, or if you're going to run a center with a dog. So you can come in here, you got plenty of room before the blank, you get through the blank, and then once you end, you got plenty of room here. So coming over, if we went in about 1 inch, so I think I'm going to make the arbor about 9 inches in length. So just a tip, because sometimes you get in a hurry and you make the arbor too short, and then you're worried about trying to get in here and you don't want to crash anything. So just something to consider when making arbors. Well, hey guys, back on the I guess making the gear for the Boyar Schultz surface grinder, and just taking a break, getting the dividing head all set up, and I rotated it down into the horizontal position, and I put my magnifiers on, and I looked at the line, and I got it on 0. I figured we'd go ahead and double check it. So I got you over here at the surface plate, got a 5/8 ground rod, and I figured we'd check it, see how close I got it. Got my old Starrett back plunge indicator that I picked up at a swap meet, and sent it off to Mark Rotowski at MR Tool Repair, and he put a new glass on it and cleaned it, and it works good as new. So I figured, what the heck, let's bring her out and see what we got. So hopefully you guys are seeing this pretty good and it's not washed out. So it looks like we were a little bit low down here, and make sure I stay on the high point here. There it is. So looking about 9 thousandths high. So this end is low. Well, it's not bad for eyeballing it with some readers on. So let me go get some tools, loosen this up, and we'll see if we can't bring this up a little bit and get it totally 0. Hang on. Well, I fiddled around with it, and I've got it almost dead nuts. So we're 0 there, and I'm trying to stay out of the camera here. Let me bring her down to the high point right there. Bring you guys over. So there's the high right there. So we are about a thou off over, what is that, almost 5 inches. So I will take that, because as I tighten it up, it wants to move just a smidgen, but this will be just perfect. So we are good to go. Let's get this thing over to the mill. Okay guys, figured I'd give you an update. The arbor is done. So here is the gear blank here to cut, and I got a spacer. I turned down this part here, so I got a nice shoulder, and then threaded it. Both ends I've got center holes to support it if I end up doing between centers. So I made it nice and versatile. Now, I didn't film that because this video is going to start running long, so I just wanted to go ahead and knock it out. It's just basic turning. You guys know what that stuff is. But they got you over here at the dividing head, and so I got it taken apart so I could switch plates. This is the plate that was on it, and this is the plate that needs to go on. And these are the screws that I took out. As you can see, they self-center. So the problem is these holes are just a smidgen too close in diameter versus these. Let me see if I can hold it up and get it in the light and show you what I'm dealing with. So the plate will go on, but it won't screw on. Can you see that? So you can see it better in there. So which means basically I got to get this lined up and then run an end mill down through it, because I've got to enlarge the hole on the outside here, and I hate to do it with a drill because then it's just gonna enlarge the hole diameter. So what I was thinking is maybe just scrap this for now and go ahead and use the rotary table, because the rotary table I got is a horizontal and vertical rotary table, and I've got plates, and I also have a tailstock for it. But I really don't need the plates to cut the gear blank, because we need to do 18 teeth, so we need to make 18 passes, and you divide 18 by 360, and that gives you 20. So real simple to you know, make a pass, rotate the table 20 degrees, make another pass, rotate it, you know, and just do it like that. So I think that's what I'm leaning to. That way I can just set this aside, and we'll get to this at another time, and we can go ahead and get this gear blank cut and start putting the Boyar Schultz back together. So hang on, guys, and we'll get over to the mill and get stuff set up. Alrighty, I figured I'd show you guys the setup. Got everything squared and true and right with the world. I figured it wasn't worth filming, since there's several other good YouTube videos out there about how to get set up for cutting gears. So I know I think the Lazy Machinist has some, so does Pierre Baudry and Mr. Pete. So if you need to learn how to set one of these things up, just check out their videos. But anyway, so this is a 8-inch horizontal and vertical rotary table. It is an import, but it is a decent quality import one. And I also ordered it with the tailstock. So, and also have adapted a 6-inch 3-jaw chuck to it. So I've got the cutter on the height I need, and we are set for our depth. We need to do 135 thousandths is what the book says. So I'm going to make my first pass. We'll cut it in half. I'll do 70, and then I'll add 65 for a total of 135 depth of cut. But anyway, so that's the arbor. That's how she came out. And let me get some light here. Since we're doing 18 cuts, it makes it real easy to do the degrees. All I gotta do is 20 degrees each turn. So I am set on 0 there, and I made a line here so I can make my dial come to 0, because normally if it was in the flat position, I'd have to get down here, and putting my head right next to the cutter is not a good thing. I really don't want a line in my scalp, so now I can work from straight above. So let me get you guys stationary and get the rotary phase converter fired up, and we'll make a couple passes. Okay, hopefully you guys can see that pretty well. That's about the best spot I can get you in right now. And got the mill set at the slowest speed, because when you're cutting gears, take your time. Don't get in a rush, because you know, smooth is fast, fast is not fast. Because if you try to go fast, then you usually end up screwing something up. So remember, don't get in a rush. And the rotary table is locked, tailstock is locked. So I think we are ready to make our first pass. Since we're just using, or should I say, I'm just going to use oil. Since the gear is we're only making half an inch of a pass, and we're only doing 18 cuts for a total of 135 thousandths depth each cut, I think oil is fine. We don't need to run coolant, either flood or spray. So let's go ahead and make some chips. Seems to be taking the 70th thou depth of cut real easy. I think the next rotation we'll try taking the full depth of cut. Let me go ahead and go to our full depth. All right, there we go. Everything still feels rigid, so that's good. Alrighty, one cut in the back. Let me unlock the rotary table. Come on. Hang on, she's stuck. I tightened her too much. Alright, got her loosened up. Let's rotate 20 degrees. Get my light so I can see. Alright. We'll try a full depth of cut on this one. Alrighty, we are through. Let me move you around. Hopefully you guys can see that fairly well. The light's not blowing it out. So there, we got 2 cuts done. I'll go ahead and do all the rest of them off camera so I don't bore you. But you get the drift of it. Well, just wrapped it up, just completed the last pass, and now I am back at 0, and hopefully the camera will pick it up. You see, we are back to our original first cut, so yay, no bozos. Alrighty, let me get this cleaned up and deburred, and we'll check her out. Well, here she is. She came out just the way we needed it to come out. I took it over to the lathe and just skimmed this side, got rid of the burrs, but no bozos, so we are good. That's what the old one looked like, so you can see the difference, how much wear we got. Let me line them up there. And let's get the rack, get a good part of the rack since this is the worn part. I'm gonna get over here, and she rides nice, just like she's supposed to. So that is awesome. Now the plan is I am just going to run a bead of weld right here. This is a tapered pin and a tapered pin hole. Goes in that way, and as you can see, there's not enough gap in between the teeth, so most likely what they did is when they had the blank, they put the tapered pin in the blank when they made it, and when they cut the tooth, the tapered pin is actually part of the face of the tooth. Don't have any tapered pin reamers, so I was looking on the internet. This appears to be a number 1, so I was thinking, all right, let's go ahead and invest in a tapered pin set, and the import set's about $100. Used American sets are going about $150, and it was over $200 to buy a nice quality American set. I did find the number 1. A guy had one for sale for about be about 20 bucks with shipping. So what I thought was, well, let's just skip this, and I thought about milling a key and then broaching a keyway in here and slide it on and just use a key. But of course the problem run into is because of the wear, I wanted a nice fit, so my broach guide is 5/8, and we made this, remember, 620 or 621, so the broach guide would not fit, so I'd have to make a custom broach guide. And then also, since the tapered pin would have to be inside the blank when we milled it, or when we cut the teeth, which means I would have to make a a tapered hole in the arbor that we made. So I figured it was just too much trouble to do all that. I figured we'll just put it on, run a bead of weld, and it'll be good to go, and it'll last for another 40 years. So that's the way I'm going to do it. And with that, this is going to be a wrap. So I appreciate you guys watching, appreciate you subscribing, and next video is going to be we're going to repair the rack. So see you guys.